Hello. It's a pleasure for me to be here. I would like to speak today about diagnostics, and when I say diagnostics, I mean not only health-related diagnostics, but also environmental monitoring. So nowadays we have a lot of issues, a lot of challenges. In fact, aging of populations, just to consider that by 2050, 2 billion of people will be more than 60 years old. Chronic diseases, 7 of the top 10 causes of death. Spending on health with a lot of 6.5 trillion. Pandemics, we have been living since more than 2 years, COVID. But also environment, a lot of contamination, chemical, biological contaminations. And considering all these, in fact, we have conventional laboratories that are working fine. These are very good because they have very good sensitivity, they have information capability, they are suitable also for basic research in addition to giving service to the people. But also they have problems related to the cost. They have problems related to the time, so they are time consuming. They are related to large equipment, as you probably know. And also they request specialized users and facilities. And also sometimes they have low throughput for what they are requested. This is why we are very much interested to work and to offer the so-called point-of-care devices, and in this context, biosensors. But for these biosensors, for these devices to be useful as point-of-care, they should be, we say, reassured. And this means that they should be able to give response in real time, should be connected with an easy sampling mode, should be affordable, sensitive, specific, user-friendly, rapid and robust, equipment-free, and also deliver to those who need it. Think just about COVID tests. So we had a lot of need about this kind of devices, and all these devices should fulfill this kind of these requisites. So otherwise, shouldn't be possible to afford our need for these circumstances. So this is why we are focused in a kind of nanobiosensors that are using sustainable platforms like paper, plastics. We are using printing technologies that are fast, cost-efficient, and we are trying to integrate nanomaterials within these platforms. And of course, trying to integrate because you need to do some electronics, you need to connect, and we are also working in smartphone-related connections with these devices in our laboratory at Catalan Institute of Nanoscience and Nanotechnology in Beaterra, just 20 minutes by car from here. So, and the idea behind all what we are doing is why not to move from what we have nowadays, centralized fabrication of this kind of devices to we call ubiquitous fabrication. So instead of distributing these devices to be used as point of care, why not to distribute the technology? But this means you need to have a simple technology like printers, fast patterning, stamping, so we can address, for example, challenges like, for example, the pandemics. You know, different kind of virus, you need very fast to address these needs. So everywhere, in different countries, people should be able to fabricate very fast and address the challenges. So this is why we are working with this kind of devices, being lateral flow one of them, based on paper, but also other devices that are really simple, based on just printing, very fast printing, being an alternative to other devices. So paper is one of them, and we heard another interesting talk about the advantages in our field. It's very interesting because paper is sustainable, is biodegradable, is very easy to do even microfluidics. You have like a zero energy device, so liquid can run by capillary forces, but also we can integrate nanomaterials. And in fact, what we are doing is putting nanoparticles, putting different other biological materials, converting a piece of paper to a sensor, and this is really amazing. This is just an example from the devices we are developing, and this is based on graphene, taking advantages of this material, using this as a simple device to control the breath that may be with interest for future application in diagnostics in addition to other fields, giving a very fast response, but as you can see, is very easy to use and of course very easy to be produced anywhere in the world. So the devices we are producing, we call these plug, print, and play nanobiosensors. We just need to design the device, the configuration, and then load the printer with right inks with nanoparticles, connect, put some receptors. In our case, we may put antibodies, DNA, aptamers, and then just operate, connect it through a smartphone. And this is just one application we did in relation to a biomarker for health disease. So it's really very, very fast. As you can see, you print as you print in your office with a office printer. So it's really very, very interesting, and you see also microfluidics occurring there. So you may have, and probably so, yesterday was a presentation in a poster by one of my PhD students and collaborators, Massimo and Giulio, who probably are here, and you could see how simple is this technology, so how we make this technology able to be offered in any place in the world and to solve problems related to any kind of diagnostics. And of course, we are moving forward, doing much more science and technology, putting always in these simple platforms, DNA nanotechnology, for example, to detect antibodies, but also to detect SARS-CoV-2 spike protein with interest for pandemics that we have been working since the beginning. This is another example of our devices, still sustainable devices we are wishing to offer, and in this case as a wearable. So instead of having a standalone sensor, you have it already in your body, and this can be used, for example, in this case for copper detection with interest for some diagnostics. And of course, these devices are useful also for environmental monitoring, and this is another example where our devices, in collaboration with our partners in Europe, were integrated in a boat, going around and trying to detect accidental contamination of heavy metals, and of course, sending the messages, the information to the end users so as to control the contamination. Of course, we need to put more efforts, and in fact, this technology is quite amazing, but still, we are trying to integrate in these paper-based sensors more nanotechnology, more nanomaterials, so as to develop the next generation of these sustainable, simple platforms with interest for diagnostics, addressing issues related to the sensitivity, issues related to multiplexing, etc., that are very important for real scenarios, either in clinical analysis, but also environmental monitoring. And of course, to do that, we need also to collaborate, and this is just recent collaborations. We are working together with colleagues at Hospital San Juan de Déu here in Barcelona, and also our colleagues in Olomouc, Czech Republic, putting together efforts and integrating more nanotechnology, graphene-related materials to these paper-based sensors, very simple, in this case, with interest for cancer-related diagnostics and therapy. Of course, to do this, to make these devices offered for such kind of applications that we call it a democratization of diagnostics is something fantastic, but you need, of course, to develop furthermore new materials, to explore new materials, but also materials with cost, efficiency, but also devices with portability, sensitivity enough, reproducibility is very, very important, and of course, sometimes you need these to have equipment free. And to do this, you need also to transfer your expertise. So boosting the research capabilities of other countries is an important issue related with this democratization of diagnostics. This is why our institute, in collaboration with Czech Republic, won an important European project, so a twinning project in which we are now trying to boost the research capabilities of University of Tirana in Albania. So we are trying to combine our expertise in sensors, expertise of oleomooking graphene, and try to help colleagues in Tirana, Albania, to develop new generation of sensors with interest for environmental monitoring, etc. So this is all I wanted to say, and of course to do that we have a lot of, we have sponsors, we have support by our institutions all over the world, and overall I would like to thank my collaborators, so some of them are missing, but those who are doing all this amazing work, this is just a part of these works, but we are convinced that these kind of devices are going to be very, very interesting in the future, and overall in what we expect and we believe to democratize the diagnostics nowadays, so as to have cost-efficient devices to address issues, important issues with our health and also environment. Thank you very much.